Hello everybody. So in this video I'll be discussing a question that I actually solved pretty long back, but it just keeps popping up into my head, and it's a very nice type of question. So I want you all to know about another method of solving this. So essentially what the question is, it's a recurrence relation type summation. They give you initial conditions and they give you a relation connecting the terms of the series, and they ask you something, right? So how it's initially done, I mean how it's supposed to be done is, you're just supposed to write down the relationship, and since they're asking you a power n divided by 2 power 3n, you want to create this denominator. So in order to create this denominator, here what you do is you divide a power n by 2 power 3n to create this. So you can't just divide this by that, so you have to divide the entire LHS and RHS by that, right? So you get this equation, and now you can just apply your summation sign on LHS and RHS. So what you're gonna end up getting, and again, here you have 2 power n plus 1 divided by like 3n, and ideally you would want to write 3n as somewhat like 3 into n plus 1, like what I've written over here, 3 into n plus 1, because that time n plus 1 n plus 1, and you'll get to know why that makes sense. So basically what I did was I multiplied by 2 power 3 in the denominator and numerator, and I got this one over here. Similarly, I multiplied by 2 power 6 in the denominator and numerator, and you get this. And if you write down a few terms of this, you're gonna understand that it's some you're gonna get like you're gonna get like you're gonna get the terms of the series, but you're gonna get everything except the first and the second. So it's gonna directly start from a3, and similarly in this part you're gonna get the terms of the series, but it's not gonna start from the first term. Instead it's gonna start from the second term, and this is of course what you want to find, so I'm denoting that by s. So if you notice quite carefully, if I just subtract, like basically add the first two terms and subtract the first two terms. If I add the first two terms, I'm basically gonna get s, and since I just can't just add, like I just can't add, right? So I have to subtract the same. So I'm subtracting these two, and similarly I'm adding the first term and subtracting the first term to create the s term, and here I just have s. And solving this, you can just quite easily solve it. 2 power 6 is 64, and you get a bunch of stuff, and you get 47. S is equal to 7, and 47s is precisely what they're asking, so the answer is just 7. And in the second method I want to teach by showing you another question. It can of course be solved, it can be used even in this. I'll give that to you as a homework. So this one is it's a little bit more complicated because you have this plus 1 over here. So I'll teach you how to deal with all of that. So what you have to do is, you have to get rid of this 1 over here. You want everything to be in terms of an or an plus 1. So what I'm gonna be doing first is, let me just write down my relation again. And if I want to write the relation for the next term, which is an plus 3, it would be 2an, one less, so it's this, and plus 1. Now what I do is, I subtract these both equations. So what I end up getting is uh, an plus 2 minus an plus 3 is equal to, hold on just a second. So what I'm gonna get is, let me just adjust the camera so that it's clearer for you guys. And this I get to an plus 1 minus an plus 1 minus of 2an plus 2 minus an plus 1 plus 1. So this just cancel, and I can so rearranging all of these terms, you get an plus 3. I'm sending this to the other side, and an plus 2 and this are gonna add up. So you're gonna get this minus, minus 3 an plus 2 plus 3 an plus 1, because this one and this one add up, minus an equals 0. So this is the equation that you're gonna get. And now you have to write down the characteristic equation. If you guys don't know much about solving homogeneous equations, you guys can definitely check out some other YouTube videos. And but here I'll just be teaching you how to solve it using this technique. So basically, you can assume an to be some x bar n sort of thing, right? So an plus 3 is gonna be like x bar n plus 3 minus 3x power n plus 2 plus 3x power n plus 1 minus x bar n is equal to 0. And I can take x bar n common, so I'm just gonna get x cube minus 3x square plus 3x minus 1 is equal to 0. And if you guys have a observant eye again, so you can quite easily factor this in your mind and notice that this is just x minus 1 the whole cube equals 0. So what this essentially means is that your x takes on 3 values, and all of those 3 roots are the same. So the general equation for a power n in this case is gonna be a times let's just call this as alpha, and this is beta, and this is gamma. So this can be written as a times gamma plus b times n. Again, if you don't know why this happens, I recommend you to watch some YouTube videos on it. Plus c times n square times gamma. Oh shit, I meant to write alpha over here, and that's gamma. And since alpha, beta and gamma are the same, this is just a plus bn plus cn square. And how we get the values of a, b and c are by our initial conditions. So we know that initial condition is a0 equals a1 equals 0. So using this, we'll see what we can do. So a0 equals 0, and if I substitute 0 for n, these both are gonna go. So your a is just 0. And a1, if I substitute 1 in this equation, hold on, let me just put this in a box, it's quite important. And if I put, since we already know a is 0, you can neglect this term, and substituting 1, you have b plus c, and this is also again equal to 0 from our initial condition. So we have b equals minus c, so keep that in your head. This is our second equation. So notice how from our initial condition we are only able to get two equations, and but we have to solve, we need another equation to solve this. That's where you can use this recurrence to find out what a3 like a2 is equal to. So if I substitute n as 0 over here, I'm gonna get a2 is equal to 2a1 plus whatever this is, and since a1 is just 0 and a0 is 0, you have a2 is equal to 1. a2 is equal to 1, which is equal to 2b plus 4c. And solving this, you can substitute this over here, like b is equal to minus c. So you get, c, yeah. So you basically get 2b plus 4 into c is basically minus b is equal to 1. So you get b is equal to minus a half. So you get c is equal to 1/2. So therefore an is 1/2 times n square minus 1/2 n. I'll just tidy this up. You get n into n minus 1 by 2. In fact, if you write down quite a lot of terms of the recurrence, and if you think really hard, you can actually come up with this just by sheer observation. So so from this is just half the problem solved. There is still a lot that you have to do. Again, I'm telling you, this is not the easiest way. I still recommend you guys to solve it like this if it's in an exam or something. So now what you have to do is, now what you're asked to find is summation n is equal to 2 to infinity a power n by 7 power n, which is, since if you notice this very well, if I put n as 1, I get a1, and n is 0, a0, which are both 0 in the numerator, so they don't really have any effect. I can write this as a power n by 7 power n, where n is equal to 2 till infinity, plus a1 by 7 plus a0 by 1, basically 7 power 0, and both of these are still 0, so this doesn't make a difference. So this is the same as summation of n is equal to 0 to infinity a power n by 7 power n. Again, you might ask, why are you doing this? Because 0 to infinity as the lower and upper bounds, and 2 to infinity is really not going to make a difference. So again, now our question has shifted from finding out what an is to actually finding this. So now I'll be utilizing the space over here, which is basically n into n minus 1 divided by 2 into 7 power n. I'm just substituting this over here. And lower and upper bounds, I don't want to write it over and over. I hope you understand. So now our real question is how to find this, right? And here the interesting part begins. So we know that 1 plus x square, like the GP, infinite GP, is equal to 1 divided by 1 minus x, where mod x lesser than 1, right? I'm pretty sure they teach you this in school when they're teaching geometric progressions. So what I can write is summation of x power n is equal to 1 divided by 1 minus x. So now what we do is we differentiate. Differentiating is basically like differentiating each and every term. Here you get 0 and this is just 1. This becomes 2x, that becomes 3x squared. So in general you get n into x power n minus 1. And if you differentiate this using like power rule, you get minus 1 divided by 1 minus x square, and you're gonna differentiate this. Differentiation of minus x is just minus 1, which you get as 1 minus x whole square. And now you might be wondering, bro, what the hell are you doing? So you'll understand that in a minute. Now I'm gonna differentiate again. Right now you must be thinking that I must be mad or something. But again, we'll get to it, right? Now, again, using the product rule, I'm gonna get n into n minus 1 into x power n minus 2. And using, like, I hope you guys know how to differentiate this. You just get 2 divided by 1 minus x cube. You get minus 2 and that gets multiplied by a minus 1, so it becomes 2. So you get this. And now this might look very similar, right? You have n minus 1, n into n minus 1, you have n into n minus 1. That is precisely what I was trying to create. And now what I'm doing is multiply by x square. So what I get is summation n into n minus 1 into x power n is equal to 2x square divided by 1 minus x whole cube. And bam, all you have to do is substitute x is 1 over 7. Again, in order to replicate this completely, like ditto, I'll be multiplying both sides by 1/2. So multiplying by 1/2, this is what I get. And I get 1/2 summation n into n minus 1 into x power n. Now substituting x is equal to 1 over 7, because 7 is in the denominator. So what I get is half into summation, and the bounds here, I'm gonna apply the same bounds. N is equal to 0 to infinity, n into n minus 1 divided by 7 power n is equal to x square by 1 minus x the whole cube. So 1 by 7 whole square divided by 1 minus 1 over 7 whole cube. I can simplify this as 1 over 49 divided by 1 minus 1 by 7 is 6 by 7 whole cube. And again, this is just 1 over 49 divided by 216 divided by 49 into 7. And boom, boom, you get 7 over 216. And there you go, that's your answer. I hope you guys enjoyed the question, and see you guys later. Or I must say, see myself later.